It happens daily. Expensive electrical and mechanical equipment fails. And when it does, motors and switches aren't the only things that are burned up. So is your maintenance budget. Repairs and replacement are expensive, and that's just the beginning. Suppose this 10 horsepower motor powers a critical production line, or the HVAC system that keeps your IT equipment operating at the right temperature. The cost of downtime makes replacement costs look like peanuts. A recent survey of maintenance professionals revealed the cost of downtime averages $10,000 an hour. Talk about your money going up in smoke. And who's on the firing line? Maintenance, that's who. Man, what you wouldn't give for a crystal ball. Something that would allow you to anticipate equipment problems before they occur. You know, like a thermal imager that shows you surface temperatures across an entire piece of equipment, so you can really pinpoint problems or potential problems. Wouldn't that be great? To quickly troubleshoot problem equipment, or verify that a repair has been made correctly. Or how about really doing planned maintenance instead of just reacting to problems? So, why not thermal imaging? Well, if you're like most maintenance professionals, you're probably thinking it's too expensive. And even if you could afford it, the technology is too complicated. Or maybe you're already using a thermography consultant, but the cost only allows you to have them come in once, maybe twice a year. But what if I told you you could buy a thermal imager and train your staff for less than the cost of 1 hour of downtime? Now I've got your attention.
Thermal imaging uses a non-contact infrared technique to measure surface temperatures from a safe distance. Temperature can tell us a great deal about the health of an electrical or mechanical system. Thermographic images show temperature variations as different colors. This image allows you to quickly see surface temperatures and identify hotspots. Hotspots often indicate problems or signs of impending failure. With a thermal imager, it's quick, easy, and safe to check critical parts while a machine or electrical installation continues to operate. Recent advances in technology have not only lowered the cost of thermal imagers, but also made them easier to use. These new generation thermal imagers have all the features required for industrial maintenance without the complexity found in traditional imagers. Beware of cameras that only capture thermal images and provide a single temperature measurement. To really benefit from thermography in an industrial setting, you need a fully radiometric imager. This enables you to get an absolute temperature reading from any point in the image. For example, if you're using an imager with 160 by 120 resolution, it gives you 19,200 pixels. Because it's fully radiometric, every one of those 19,200 pixels is stored with a temperature measurement. All these data points can be recalled to disclose the exact temperature of the area of interest and be used for detailed image analysis or trend analysis of multiple images over time. That's what makes fully radiometric thermal imagers such a powerful predictive maintenance tool. All Fluke thermal imagers are fully radiometric, making them excellent for finding potential problems before they cause actual failure. Fluke IR FlexCams take thermal imaging a step further with IR Fusion technology. Fusion links a real-world visual image with a thermal image. It merges the two images into one, with the possibility to blend between the two images or create picture-in-picture combinations. Both the visual images and thermal images are available for use in reports. This will speed up documentation by reducing the need to look for individual images taken with a separate digital camera. IR Fusion helps to better identify and report suspect components to enable the repair to be done right the first time.
There are many ways thermal imaging can help you conduct planned maintenance. We're going to take a closer look at some of the most common ways.
Thermal images are powerful aids for identifying power quality related problems in three-phase electrical panels. Even a small temperature difference between phases might indicate an unbalanced or overloaded system, bad wiring, loose connections, or problems with harmonics. Such power quality related problems could soon lead to a motor overheating and eventually breaking down, or an electrical short circuit bringing the risk of fire. When checking for power quality related problems, ensure you capture thermal images of all electrical panels and other high-load connection points such as drives, disconnects, and controls. Check panels and other connections with the covers off, using proper safety protection and practices. By capturing a thermal image of all three phases side by side, you can quickly spot temperature differences between the individual phases. Even a small difference of a few degrees Celsius should be further investigated. If the temperature difference between the phases is above 15 degrees Celsius, immediate action must be taken. Let's have a closer look. Here you can see a thermal image of a three-phase system. The temperature of phase 2 clearly shows about a 21 degrees higher temperature than the other phases. This is a clear indication that something is wrong. The temperature distribution over the cable suggests a bad connection, although an unbalanced load, overload, and harmonics can all result in a similar temperature pattern. To understand what actually causes this temperature increase, additional measurements need to be done. The loading on each phase is easily checked with a current clamp. For more detailed analysis of three-phase power problems, a power quality analyzer is the ideal tool. Hooking up a power quality analyzer will clearly show any unbalance in the system.
Another area where thermography is a maintenance professional's best friend is electric motors.
A recent estimate of the number of electrical motors used in industry around the world is over 40 million. And these motors use 70% of all the electricity consumed by industry. So keeping your motors running in top condition is extremely important. When checking electric motors, do so under normal operating conditions. Unlike an infrared thermometer that only captures temperatures at a single point, a thermal imager captures temperatures at thousands of points in real time. A single image includes all critical components, such as the motor, shaft coupling, motor and shaft bearings, and the gearbox. All motors should list the normal operating temperature on the nameplate. Even though a thermal imager cannot see the inside of the motor, the outside temperature is a good indicator of what's happening inside. If a motor runs at a temperature 10 degrees Celsius higher than specified, its life cycle is halved. This increases both maintenance costs and the risk of expensive downtime. A motor running at higher temperature than specified may be due to bad cooling, power quality related problems like harmonics or unbalance, or insulation problems with the motor windings. Mechanical problems such as bad alignment or broken ball bearings could also cause a motor to overheat. A thermal imager quickly checks the operating condition and finds possible hotspots. Problem solving may be as easy as cleaning the air intake grills. For more complex problems, especially those related to the power, it's advisable to use additional measurement tools like a current clamp. The condition of the motor windings is easily checked with an insulation tester. Insulation failures should be repaired as soon as possible. An overheated bearing is easily seen using a thermal imager. Misalignment or bad lubrication might be the cause for this bearing overheating, meaning it is likely to fail if the problem is not rectified.
If power is the most vital physical asset in your facility, then process is next in line.
Pipes, vessels, and steam traps are not only hard to reach, but can be hazardous to be around. Using a thermal imager from a distance makes measuring the temperature of these components much simpler and safer. Thermal images reveal the comparative temperatures of system components and how efficiently and effectively they are operating. Thermal inspections help increase the detection rate of problems in steam systems, for example. Maintenance work is often carried out reactively. When a problem occurs, it is fixed as soon as possible. Thermal imaging can help you to move away from this reactive maintenance approach to a more predictive maintenance mode. By regularly taking a thermal image from the most critical equipment, you will be able to see the gradual temperature change over time. This trend information helps predict the status of your machine's deterioration. A rise in temperature signifies an impending problem. This will allow planned maintenance at a convenient time and avoids an unplanned shutdown. The Fluke thermal imagers are supplied with reporting and analysis software. This software allows you to set up a predictive maintenance program. Images taken during regular inspections are easily compared to previous ones, helping to identify potential problems before they cause failure. A detailed analysis of the image using dedicated software can also include changing the image parameters to zoom in to potential problem areas. The software's report generator makes it easy to communicate findings and repair instructions to the maintenance department. Fluke software can be loaded on as many computers as you need, as there are no additional licensing fees.
Our predictive maintenance program has been a success largely due to the success of the thermal imaging program that we've started. We're able to shoot steam traps and check for proper operation of those. We're able to shoot bearing temperatures and decide based on temperature and other factors, of course, whether that bearing's going to go catastrophic or not. We can schedule our line shutdowns accordingly and prevent the catastrophic failure.
We've spent a lot of time talking about thermography. And as I've said, it's a powerful tool, but it's not the only tool Fluke provides you to conduct planned maintenance.
Fluke also offers a full line of industrial test tools for industrial maintenance professionals. Rugged, reliable, and accurate, Fluke tools are built to withstand tough environments. From thermal imagers to power quality analyzers, and current clamps to insulation testers, you can depend on Fluke tools. Fluke, keeping your world up and running.